that was a deep dive into cognitive and adaptive processing and programmable processing. But as all of us would imagine, if the processor is the mind, the neural network in the machine or the munition or the device that you're talking about, the data acquisition point, which is the sensory bit of the world, if you do not have data acquisition, we will not be able to perform all the brilliant operations that he's been talking about. To connect to that thread, I would like to request now Mr. Rahul K. Mathur from TE Connectivity to talk about how sensing is key and what are the kind of things that they are doing as TE Connectivity within that space. To introduce Rahul, he's a director for the A&D business at TE Connectivity. He was handling the distribution for TE in North America, and he himself is an entrepreneur, so I'd also like to get some insight from him that would help our members here on making a successful business in the A&D space, because he did operate in the same space. And he's an engineer and an ex-MBA from UCLA Anderson School. With that, I'd like to introduce Rahul and up for you.
Thank you very much. So it's a pleasure to be here today in front of you to talk a little bit about our perspective on the space market, and also a little bit about what TE is doing in the aerospace and defense and space markets.
Impossible. For the few, this word is not an endpoint. It's a starting point for tomorrow's breakthrough. For them, no idea is too far-fetched. This endless quest forward by engineers has put the world at the dawn of a golden age of innovation. Today, we're dazzled by technology that didn't exist just a few years ago. Tomorrow is being born before our very eyes. And TE Connectivity is at the cusp of this transformation, straddling all that can be done and all that will be done. Our engineers, working with other engineers, custom making the sensors and connectors that lead to new ways of living. Robots responding to human activity, roads talking to cars, the always-on internet, technology revolutionizing healthcare, reshaping industry, redefining the future. Collaboration that's making our world safer, greener, smarter, and more beautiful, turning today's impossible into tomorrow's awesome. TE Connectivity, every connection counts.
So with that, I'd like to start off by just giving an overview of what is the global space economy. So as you can see, it's about $384 billion, out of which commercial products and services, a majority of it, which is around 211, and then commercial infra and support is about 96. Then the government also has a big portion of the space economy. It's about $76 billion, mainly the US government is the primary investor in that area. So the way to look at the industry is downstream and upstream. Downstream is where they use the infrastructure that has been created, and upstream is the creation of that infrastructure. A quick snapshot on breakdown of the space economy. On the left is what has been traditionally where the economy, where the markets have been. On the right, on the left side, on your right side is some of the new areas that are coming up. So things like suborbital human spaceflight is one area that's really in the news a lot recently. You also have the small satellite manufacturing, and I think that's a very nice area for India. Right across from us is the NASCOM Center, where you have a startup space, as well as I know IISc is also doing a lot of work there, where there are a lot of startups that can come into that space. So that's quite exciting. Now moving on just quickly to some of the drivers, trends, and challenges that we are seeing in this market. Of course, technology is one of the key drivers. There's a lot of things that are coming into this market from outside the market, as well as things that are being developed in the market. And I'll go a little bit further into that later on in my presentation. We saw in the previous presentation about data. So data is one of the areas that is really booming, and one of the challenges that we have is how do we transmit all of that data to the ground, make sense of it. So there's a lot of change happening through that. There's also some strategic areas that countries are looking at, both for military applications as well as protecting the space assets that are there. I'll talk a little bit about that later. And the new things that are coming up in the human flight development. So areas where we're looking at putting people on Mars, setting up an ecosystem there. I think recently there was an article about how SpaceX has got their first customer who's going to be traveling into space. So these are some of the key drivers that we are seeing. There's also trends where we are seeing private investment coming in. There's an explosion of micro, nano, and pico satellites. Also, more and more with technology developing on the commercial side, we're seeing where earlier what was addressed by the military dedicated satellites, that's now also being addressed by commercial applications. And of course, there's a lot of consolidation happening and more to come. Companies acquiring horizontally other companies in their space, working with partners where they have areas of development, and also some financial consolidation where PE firms are looking at acquiring companies, a portfolio of companies that probably they will be looking at going for an IPO later. So these are some of the trends. Some challenges, with the advent of UAV technologies and the improvement, some of it around the time that they can fly, some even going up to possibly a few months. There is an aspect where some of this could substitute some of the satellites that we're using. There's also more satellites in space. There's satellites that have been launched a long time ago but are not active, and those threats of damage to them is increasing. And the last one is still for large satellites, large programs. There's still a huge developmental cost associated with it. So even though there's a lot of advent of newer technologies, that's an area where primarily governments and high investments are required. So going a little bit more into the technology advancements, so miniaturization is one of the areas that TE as a company is very focused on. We have a breadth of products that we have introduced in the market that are lighter, faster, smaller, and that's really helping to make the size of satellites, the weight of satellites come down. Just as an example, the average weight of a military satellite in 2011 was about 3.5 kgs, whereas now it's about 1.5 kg in 2016. So that's the kind of change that's happening in terms of weights. There's also developments in newer technologies like actively scanned array radars. There's an interesting development with micro mini satellites coming out. There's a need to have propulsion systems, and there are projects that are currently working where they're using ultra purified water as one of the elements and to propel it. There's also work around reusable satellite vehicles. I think we know the global example, as well as in India. That's one of the areas that we are focused on. Second is demand driver is the data part of it. So we heard previously from Xilinx a lot around that. I think one of the areas that's quite interesting is looking at with the Internet of Things, can machines, when machines are talking to each other, can they actually talk via satellite communications? So that's an interesting area that, that is developing. We spoke a little bit about military strategic. One of the areas that, that is also important is secure messaging. And one of the technologies is the quantum cryptography technology that's coming up. I think China has made a lot of progress around that and helps secure communication. And the last but not the least is human flight. That's an area that's probably the future of space. Talking a little bit more about micro, nano, and pico satellites, I think more and more what we are seeing is COTS being used in them. Where you have commercial off-the-shelf products that can be easily available are at a much lower cost, and so that's one area that's helping reduce the size of the satellites. And more, the idea is to launch in areas of interest swarms of satellites where you can launch them quickly. You don't need expensive mechanisms to launch them, they can give you a much better coverage in the areas of interest. We spoke about the commercial partnering with defense, and that's where we are seeing with improvements in resolution, etc. There's an opportunity for the military side of the to use more commercial satellites. A little bit on the consolidation. So one of the examples over here is where was in the news last year was Northrop Grumman acquiring Orbital. That's an example of horizontal consolidation. There's also firms that are buying vertically and acquiring technologies. So Planet, a company called Planet, bought last year Google Sat Constellation. So that's some of the trends that we are seeing. And what we also look at, foresee is that there is a lot of increase in bandwidth that's going to come into the market by 2020, about 4 times what it is currently, whereas the demand is not going to be as high. So that going forward could also drive additional consolidation in the market. In terms of the challenges, UAVs is one area. So there is some ultralight UAVs that are coming that can stay up in the air for several months, and they could be used for some of the applications for which we are currently using satellites. The other is damage from space debris. So there's just last year about a 50% increase in the number of objects compared to the previous year that were launched in space. Almost 357 objects were launched last year. So and a lot of them are inactive, and as time goes by, those satellites could cause damage to others. And the last is on the development cost of large satellites. What we're seeing in the market is trends of countries working together, different companies working together, and I think partnerships between government and private is one of the requirements going forward to have a successful program. So we'll focus on a couple of areas a little bit more. One is on spacecraft. So this is where it's an industry of about $37 million. And what's interesting to see is there's been a rapid increase in commercial satellites. So there's almost about 240 odd satellites that were launched last year, compared to around 80, 90 the previous year. We think that this trend is going to continue in the future, and a bigger share of the pie is going to go to commercial launches. Again, on the right, you can see some of the areas that had the maximum number of satellite launches. So Earth observation was the highest, followed by remote sensing and optical imaging and communications. Just ask you for a couple of minutes for a small video.
The challenge that NASA is facing in this is to be able to launch this, 1-ton rover 350 million miles to the surface of Mars and get it there safely without damage, and then have everything power up and all the critical systems work properly first time, because failure isn't an option. There's no way to go out and repair a vehicle like that on the surface of Mars. Fortunately for this particular application for NASA, we were able to build upon prior work that we have in satellites and other space exploration. We have relays and contactors in GPS-3 satellites, for example. We've been on every lunar, every Mars mission to date. The high voltage relay that we produce for Curiosity, it's a 5,000 volt switch that's capable of switching 35 amps. If you did the wattage, that's a tremendous amount of power. It's amazing that this device is the size of a roll of dimes. And it all requires collaboration with our customers. We got to have those discussions as to what's the particular parameters and what direction is that force and how long is it there and what's the amplitude of it. And then we can tailor our product to be the smallest, lightest, and highest performing product for any application. With our research efforts, with my team and also with advanced development, we're working on technologies that will change the way people do power distribution in the future.
So I think the key in that video was the collaboration piece of it. So as a component supplier, for us, we follow what the customer requirement is. And we have a team of engineers, field application, as well as in-house engineers that really works closely with customers to develop what solutions they're looking for. So here, in terms of spacecraft, here are some of the areas of focus for TE. So it's around high-speed performance, power management, there's miniaturization while keeping high speed, and also sensor solutions. So as was nicely explained during the introduction, we need to be able to get the signal to where it's required, as well as to be able to sense have sensors in order to make sure that the status of our systems is good. So moving on to launch vehicles, that's about a $7.5 billion industry, and it's an area where again the US has started to increase after being flat for many years in the past. It's in terms of the composition, commercial is about 33%, military 37%, civil government is about 30%, and human space flight is what's around 13%. Couple of areas that we think is going to increase going forward is going to be on the human space flight area, as well as on the commercial area. That's the trend that we've been seeing. So again, TE has solutions in for launch vehicles. We have integrated assemblies that we provide. There's because of the need for because of the high vibration and temperatures during launch, we have a range of products that support that. We also have that in both circular and rectangular. And TE is is always looking at the next generation products. Some examples of that is on the bottom right-hand side, where you see some cables that are being developed for our customers globally. So over here, just want to emphasize that we are in a great market. It's 16% is what the Indian space budget is increasing by. So it's great for us to be part of this ecosystem, and India is a very important market for TE connectivity. And also TE has been in India and supporting the space industry from the 1960s, both on launchers and on satellites. We've set up our own manufacturing facility here. We're doing a lot of earlier work that was being done in our US or France facilities are getting transferred over here. We have a very strong engagement which we want to deepen with the Indian space industry going forward to build more and more products and design products in India. Here's some of the latest technologies that we're bringing in a lot. It's interesting around connectors and sensors and cables. A lot of different technologies go into it, and we have an advanced manufacturing facility and design facility in the US, and what their main objective is to look at what are the newer technologies that are coming up, how we can be in advance of what our customer requires, so that when you come to us with a requirement, we're able to shorten the time that we take to be able to come with those solutions. With that, thank you very much for your time.
May I request Mr. Viresh to hand over a moment to Rahul before he moves.